So for part 4 of this assignment, we're going to be using this thermistor right here as in a voltage divider circuit in order to power up this LED over here, such that when I pinch the thermistor, which will make the temperature increase, that LED will increase in brightness, and when it's at ambient temperature, it'll be very dim or close to off. So let's see how this goes right here. This is the code I'll be running. It's the thermometer program from Freenove project 10.1, except it's modified so that it'll actually drive an LED. So the temperatures are computed here. This all came from the code, but then I added this mapping function right here to map roughly 23 degrees at the bottom to 35 degrees at the top for the duty cycles. So at roughly 25 degrees and lower, it'll be at 0, and at 35 degrees or higher, it'll be 100. I had to also validate the data to fix an error when the PWM duty cycle becomes less than 0, greater than 100. Since this is a linear mapping, sometimes it can fall outside the boundaries. Obviously, I also had to add an LED pin and create a pulse width modulation object. More details on those modifications can be found in the supporting documentation. Let's take a look at the output right here and run the program. So as you can see, we're currently at about 22 degrees ambient temperature, and the LED is off. Now, let's see if I can get in a good position here so you can see it. As I pinch the thermistor, the LED turns on. And you can see here, the temperature is floating around 33 to 36 degrees. It varies quite a bit. When I release it, it starts to slowly return to the ambient temperature, and you'll notice that the LED starts to get dimmer. Very, very slowly, but it should be noticeable. Starting to flicker a little bit as it gets close to off, and now it is basically off. We've dropped below 23 degrees again. We could do this as many times as we want until the program's over, and it'll just keep doing that loop. It heats up a lot faster than it cools down, which makes sense. There's a lot more heat in my fingers than there is in the air, and it takes the air a lot longer to reduce the temperature than my fingers to increase it. All right, so there you go.